I know some of you have waited so long for this and I get so many requests, but finally the day has come and we built our own Butterfly CFD indoor airflow script. Previously we looked at the example files, but they are not very self-explanatory. I understand it's hard, and that's why this step-by-step guide should help you to understand, and then you can refine and learn more about the indoor airflow. Please note, you need to start your Rhino in admin mode. Right click and start as administrator. You should be able to do that even though you're not the main admin for your computer. Second, you need to install Bluecore CFD 2017. 2020 doesn't work. Alright, so we're here. We're gonna start with a completely fresh script here. Go into the Butterfly folder. Here we have all our tools. I created a very simple box with a surface which functions as the inflow, and I cut out a window. This is my outflow. Same position as the cut, but you need the cut. Butterfly, we don't need this. Butterfly create case from folder, we don't need that. This is if you already have a case somewhere saved. And then for the outdoor airflow, we always use the case from tunnel. The tunnel basically builds its own box with an inflow and outflow. This time we want to use our own geometry as a boundary. That's why we need to use the case, create case from geometries. That's a bit different. And for the butterfly geometries, we need to specify boundary condition. The boundary conditions are here. We didn't use that before because the tunnel already takes care of that. But now we need to define what is what. And that's really the main difference. We need geometry, of course. This is gonna be my wall, one B-wrap. I'm gonna hide that right away. Only my windows cut out. I don't think I need to cut out that, but let's see. And I also added here a line. This will later work as my function, my vector. I will get there in a minute. We need a panel with a name. I can also change the color, by the way. You know, if you always wonder why some panels are white, that's why. I call this walls. Always make sure you just use simple alphabet, no special letters, because you might run into problems. You need to provide a name. That's mandatory. Don't change the name here. Don't change this. That doesn't work. That will cause problems. This is actually already what we need in order to create a butterfly geometry, but we need to, in that case, we need to define the boundary. What is the boundary? Otherwise, we're gonna have a problem. We can also put in here the case from geometries right away. That goes into here, and it's nice to let this run for now, so we can always see when it's actually ready. Call it indoor flow. I don't add any spaces in between. I think, yeah, it needs to be simple and no spaces. Maybe underscores maybe work, but spaces, I'm not sure. Let's keep it simple. I add here the butterfly geometry toggle. I need a toggle, a Boolean toggle. Can I put this here? Yeah, it creates already kind of a boundary. That's interesting. That's why I want to keep this here so we can see what's actually happening. It doesn't give me an error. That's a good sign, but we need to specify the boundary. In that case, the boundary is a wall boundary. We can put this here, and now we can just copy this whole thing. I call this inflow, and this of course doesn't work. We have two options for inlet. Let's use the first one for this, two methods, and we need to provide a velocity vector. We use just a curve here, this tool. We add this here. That's why I added here like this line, and I specify 1 point. It's okay. I have set these 2 points. That creates a vector for me, and the vector is 1 meter long. That also represents the speed of the air, 1 meter per second. We could build it more sophisticated, but let's keep it simple for now. Just understand what the things do. And we can add this also here into the geometry. Yeah. And now we can add a third one, and this is going to be my outflow. Let's be nice, and we really use the right tools here. Adding here a surface, and then I do the same here, just to make sure. Inflow. If you hover over the output and if you say null, then there's something wrong. So you need to see that butterfly geometry, grasshopper, and then the name. That's important. And you need a name. It's mandatory. I also hide these. And what I'm gonna do is I just add a B-wrap wireframe. That's what I want. B-wrap wireframe, so I can turn off this. So that should work for now. So I don't need to see the walls. And we can also go into a different mode maybe. That's nicer. Some things are not mandatory, but as you remember from refinement levels and mesh settings, and normally these are set by default, but we can always add here, for example, the high quality. I will do that. We can use it for all three geometries. They're not very complicated at the moment, but they could be, and then this makes definitely a difference. And the same for the refinement level. We could use here just two numbers. We just need two numbers. Refinement levels are always defined by a minimum and maximum. I will just follow what's happening in the example file. Okay, I think that looks good. Here, no, there's no error. That's also good. That means that first thing is done. Okay, with this in place, we can just jump in and create the block mesh. It's pretty much very similar to what we did in all the other CFD videos. We need a write and we need a run toggle. That was very quick. We can look at the case. We can look at the mesh if we want and see how that will look like and how that looks like. Let's keep this separate better. So this is our current case. It's actually funny that this is larger than the box itself. Let's see what that how that works. With that in place, we can already start with the snappy hex mesh. The block mesh basically divides, and then we refine everything with the snappy hex mesh. We also need a run and write button. Also goes very quick. Can move this here and have a look how this looks like now. Okay, create this like it's almost like a fillet. That's not what we want. We don't want that. We want to have a hard edge, and we can achieve that with this snappy hex mesh dictionary. I don't know why they call it dictionary. It's basically, for me, I would call it settings. You can see here they set this to false. Can go here and set this to false, and now it's like a hard box, and it's also exactly now it also fits exactly the original room massing. All right, that's already quite a lot. We continue in the next video. Joke. Of course, we'll continue now. Let's turn this off for now. Don't need to see this now. We can already jump into the solution, butterfly solution. We just add here the case. We again need a write and run button, but first we need to set the recipe. The recipe is in that case the butterfly steady incompressible recipe. We will do the heat transfer another time. Recipe goes in here. There are already some properties in here, so we can just use that as it is. Please read about turbulence models. We discussed it already. You can look it up and it will explain you what these different models do. Okay, we need then solution parameters. The solution parameters. And here you can see we need probes and the control dictionary. Butterfly control dictionary. Here we can set the start time and the end time 1000. I think that's fine. Let's keep 1000 for now. This is just on how many iterations it calculates. The more iteration, the finer the calculation, the more exact the calculation. By the way, this is just how accurate the model is and not how accurate it translates into in a real world. I can put this in here. We can leave that the 1000. Let's skip the 1000. We have here the butterfly probes. It's always actually really. It's always like from one input you add the tool and it will tell you which tool you need next. And then we need points and fields. In that case we need some of these. I'll just put U as a field. That is the velocity. So you need to define what you want to test. U is the velocity, P is the pressure, one more thing I also forgot again is I need to also cut out the inflow. Now I have two surfaces here. This is the wrong one. This one I can keep. My walls have changed again. Now hopefully it should work. I will keep it simple. Let's just have a surface in here that will create my points for now. I can add it here so we can see how they move in space, hopefully. We can use, for that, we can actually use the Ladybug generate point grid. We can add here a surface and we can specify the grid size here. Offset this, and we don't need that. Now we have points, we have vectors. Now hopefully now it should work. That looks already much better. No, I made a big mistake here. Of course, this is I forgot to change this outflow. This is the outflow, and the boundary is actually an outflow outlet boundary. Yeah. Okay, it's calculating now, as you can see, but we can't see any vectors here. Now, if you want to look at our vectors, then we need to make them visible. We have the solution. There are several other tools here we can look at. First of all, here's the butterfly load probes, butterfly load probe values, the residuals, and load skip probes. Put in here the solution. Actually, now I don't need the pressure. I can actually remove the pressure if I want. I only want to check the velocity, and we take the solution, go into here, and we can then specify what kind of field we want to look at. Panel. Okay. We're gonna run this again. It seems like I have some other issue again. Today it's not my day. I maybe have made a mistake here. Sorry, again. I think that's what we need. Yes. Now we have our... Sorry for that. Now we have our values for the field U. Interestingly, I don't know why load probes don't work, but we can actually turn this off. Don't want to see that. I don't want to see the points. I want to make the vectors visible. And how can we do this? So I don't know why it gives me this error. It's actually ran. I have the values. It doesn't matter really. We can let's have first a look at the vectors and how we can make them visible. So this is actually very simple. We just need to use our points which we created here. If I put this here, I can see my points again. Now I can create vectors. Here, just the vectors here. These values, the values from the solution. If I look into here, these are my vector. This is the vectors. And if you want, you can actually check the vector length. With this tool, you can check the length of the vector. Now this tells us the speed, the velocity at each point. If we go back here and look at what we actually have set, then we have here 0.5 as a speed, 0.5 meter per second. We could make this, of course, more sophisticated here, but again, let's keep it simple. And we have our points. This is the origin of each vector on each point. So these values here correlate with this. And if I now add a display, I want to make these vectors visible. I can use this one, or this one is a bit more sophisticated. So if I just use this one, then I can add here the anchor point for the vectors and then the vectors. Let's use the more sophisticated preview. We can add this here, can add our vectors here. Gives us already a bit of better understanding. And at the moment they're just black, and maybe now we could add a color. So if we want to color these, then we need to use a gradient. We can set our own colors, of course. We have the points here, we have our values here, the vectors, the length, and we can use this the bounds tool to get the minimum and maximum, so we know what is the lowest and what is the highest. And then, so we get this range between the lowest and the highest number. And we can then deconstruct that domain here, deconstruct the domain, put this in here, and then this is our lowest, and this is our highest. And here we need to add all our values. And this then goes into here. It's actually not the opposite. I want to have this here and this here. Of course, we can play with the colors. We can also use a different preset. Maybe use this one. It's maybe nicer. Yeah, I think it's already pretty good. It's actually, this is also not, I don't want that preset. This is the opposite what I want. So actually, now in that case, I want to like have the faster speeds in red and the slower ones in blue. And let's maybe recalculate that whole thing. The easiest way I've always found with Butterfly CFD is to just type a different name here. Again, be aware that every time you create a new case, it's gonna create a new folder and it adds all the calculation in there. It goes really quick. Now we could add more of these windows, for example, or more inflows. Also, we could change the velocity by just changing here the number. That also reminds me that now we have the problem that these vectors are way too long. I increased the speed here. I changed the length and now it's 1.6 meter per second, the velocity. The start velocity. That means we would need now to change that here. We would need to find a way on how to control the vector length. This is actually really simple because we just need to go here, add a division and something where we can control the division here, maybe 10, I don't know. With that we can now divide it by 0, of course doesn't work, but in that way we can control the length of that vector. So now another way we can deal with it is if, for example, we would have the pressure, we could also calculate the pressure and then add a heat map to it and look at that as and look at the heat map output of that same mesh. I'll just just show you what I mean by that. So we could have here a Ladybug spatial heat map. That is actually just a mesh, represent the mesh. Here we have a mesh. This is a mesh output. This was created for us. And then we could add our values. And this gives us a heat map of the speed. And we could, of course, use the pressure here or temperature. Now the problem is that we don't see the vectors. So that's why, so we could move the mesh. Let's move the mesh and that should help. Move geometry. We can provide -0.2. No, that's not what I want. So I can change the height of my mesh here. The problem is now the mesh, the heat map looks exactly the same. That's not cool. We could use a different preset here, or we could decide if we don't use colors for the vectors, just have the heat map. Or you just change the colors of the heat map. That's also possible. So there are thousands of options on how to visualize that. It's really up to you. Alright, I hope that makes things a bit clearer, and let me know if you have any question. Alright, see you in the next video.